In this video, we're going to finish up this unit, and we're looking at application of logarithms, more specifically on the Richter scale, and also on exponential decay. So the Richter scale is a log scale for measuring the intensity of an earthquake. Each increase of 1 unit on our log scale represents a 10-fold increase in intensity. For example, an earthquake of magnitude 9 in Japan in March 2011 was 100 times as intense as an earthquake of magnitude 7 in the same country in July 2011. So here's the following formula we are going to use. M is equal to log I over S. M is the magnitude of the earthquake, I is the intensity of the vibrations, and S is the intensity of a standard earthquake. So let's do an example of this. In June 2010, Ontario and Quebec experienced an earthquake with a magnitude 5. In January of the same year, Haiti experienced an earthquake with a magnitude of 7. We want to calculate the intensity of the Haiti earthquake in terms of a standard earthquake. This means I'm going to leave this in terms of S. So here is our formula. I know the magnitude of the Haiti earthquake is 7, so that's M. And I'm going to fill this into our equation. Now from here, I will change it to exponential form, so I can express this in terms of S. So your base is 10. The power is 7, the answer is I over S. And I want to find the intensity, so I'm going to multiply both sides by S. So I is 10 to the power of 7 S. In other words, that's 10 to the power of 7 times the standard earthquake is your intensity. And that is a lot. Now we're going to calculate the intensity of the Ontario-Quebec earthquake in terms of a standard earthquake. Same sort of thing. I am going to use our formula. And for our magnitude for our Ontario-Quebec earthquake is 5. I'm going to change this into exponential form. So our base is 10. The power is 5. Our answer is I over S. I'm trying to find the intensity, so I'm going to multiply both sides by S. So this means the intensity of our Quebec Ontario earthquake is 10 to the power of 5 times the standard earthquake. Now I want to know how many times as intense as the Ontario earthquake was the Haiti earthquake. We're going to do that comparison by the following. The intensity of the Haiti earthquake divided by the intensity of our Ontario earthquake. The intensity of our Haiti earthquake was calculated in part A, which is 10 to the power of 7 of the standard earthquake. The intensity of the Ontario-Quebec earthquake was 10 to the power of 5 of the standard earthquake. So our S's are going to cancel out, and then we have the same base, and we're dividing, so we're going to subtract the exponents. So that's 10 to the power of 2. And that's 100. So that means Haiti was 100 times as intense as the Ontario earthquake. And that's it. For our last example, we're going to look at exponential decay. So this is a function that models exponential decay and has the form of y equals a, k as your base to the power of bx. And k is a number between 0 and 1. K is also called the decay factor. So for example, we have a function p is equal to 101.3 multiplied by 0.88 to the power of h. And this models atmospheric pressure measured in kilopascals. We are looking for the altitude in which the atmospheric pressure is only 10 kilopascals. And h is the altitude in kilometers. So here is our formula. We've been given P. It says the atmospheric pressure is 10 kilopascals. So that's your P. I'm going to replace P with 10 then. And then we're looking for H, which is our altitude. And you can see right away that we have an exponential equation that we're going to solve for. I'm going to try to isolate the 0.88 to the power of h and then isolate h afterwards. So my next step then will be divide 101.3 on both sides. The reason I'm leaving this as a fraction is to get the most accurate answer at the end. And it is okay to put this into a calculator right away, but you do need to keep every single decimal place in because it will affect your answer at the end. My next step from here will be to take the logarithm of both sides so I can isolate h. So that's log 10 over 101.3. is equal to log of 0.88 to the power of h. Using our power rule, I'm going to bring the h down. And then I can divide both sides by log 0.88. I could also expand this logarithm using our quotient law. So it's going to be a bit easier for us to put in the calculator. And this is all equal to h. Your very last step is to put this into your calculator, and you should get 18.11. And this is in kilometers. I'm going to answer this question as a sentence because it was a word problem to begin with. The altitude is 18 kilometers when the atmospheric pressure is 10 kilopascals. So again, you know this is an exponential decay question. Because of our base, it's smaller than 1, but larger than 0. And that's when we would know it has a decay factor for us to